Hello Year 8. Today we are starting on area. Now area is the amount of space inside a shape. Okay, so we learned about perimeter. We spent 2 lessons doing that, and that was the distance around the outside of a shape. But area is the space inside. And when we find an area, we will have units in millimeters squared, centimeters squared, meters squared, kilometers squared, or a special one that is called hectares. Now a hectare is 100 meters by 100 meters, or it is 10,000 meters squared. Okay, now the formulas that we're going to be using today for area are the square. The area of a square is the side times by itself. So we're going to call that S. So we're going to go A equals S squared. That's how you find the area of a square. A rectangle, there's a diagram here of a rectangle. We have a length and a breadth. To find the area of the rectangle, you multiply those together. Area equals length times breadth. And we have a triangle. So a triangle, we're going to do B for base, H for height. And the area of a triangle is found with the formula A is equal to half base times height. Some people like to write that formula slightly differently, with A equals base times height all divided by 2. It means the same thing. I'll probably be using this first one here that I've highlighted. We're also going to combine some of these shapes together to make what we call composite shapes. So if we need to find an area of a composite shape, we would find each of the areas separately and we would add them together. Okay, next we're also going to have to convert between units of area. Now this diagram looks really similar to the one that we had for converting distances, converting lengths. Okay. The only difference is when we have millimeters squared or centimeters squared, meters squared, kilometers squared, is that we square each of these numbers around here as well to convert them. Okay, so let me show you how to do that. We have some examples down here. Try and get them both on the screen at the same time. So example number 1, I want to convert 0.578 meters squared. So I'm starting here at meters squared, and I want to go to centimeters squared. So I follow the arrow and I times that by 100 squared. So down here, we would write down 0.578, and we want to multiply that by 100 squared. Now when you square something like 100, what that does is it doubles the amount of zeros. So it would be the same as 10,000. But you don't need to remember that. You can get your calculator to do all the work for you. Just typing in 0.578 times by 100 squared equals 5,780. And that's now centimeters squared that we've converted that into. All right, let's try the next one. I want to go from millimeters squared to meters squared. So millimeters squared are here on the end. To get to meters squared, following the arrows, I'm going to have to do 2 jumps. Divide by 10 squared and divide by 100 squared. So let's write that down. We're going to go 65100. We have to divide that by 10 squared and then divide it by 100 squared. So 65100 divide by 10 squared divide by 100 squared is 0.0651. And the new units are meters squared. Okay, good. So the next thing you want to do is to find the area of some of these shapes. So I would like you to stick to 3 lines of working out, please. The first line of working out should be the formula. I want to make sure that you can correctly identify the shape and write down the right formula. So this first shape is a triangle. So you can look at that table above, but the formula for a triangle is A for area equals half the base times the height, half BH. Now the base and the height are these two numbers here. The base is 21 and the height is 19. So the second line is to substitute those numbers in. So half, remember there's times in between each of these. So half times the base, which is 21, and the height, which is 19. The third line is to use your calculator to work out what that equals. So half times 21 times 19. So we want a decimal, so press the SD button. 199.5, and because this is area, it will be centimeters squared. Okay, so they're the 3 steps, 3 things to do for your working out. Part B, this shape is a rectangle. The formula for a rectangle is length times breadth. So we start by writing that down. A equals length times breadth. I like to use capital letters because if you go A equals L times B, the L can look a bit like a 1. So I tend to go to capital letters. So continuing from there, the second line is to substitute into that. The length is 10 and the breadth is 5. It actually doesn't matter if you call them the other way around. If you went 5 times 10 and you work that out, 10 times 5 is 50. And that will be centimeters squared. Part C is a triangle. Now the trick with this question is there's actually 3 numbers there. Our formula for a triangle is half base times height. The base and the height will always be connected by the right angle. Okay, so even though the triangle looks a little bit weird, the base is going to be the 80 and the height is the 1.2 meters. So that means that this 1.5 meters here is just there to distract and confuse us. So try not to fall for that trick. So I'm going to use those 2 measurements there. The other problem I have with this question is that this one's in centimeters and this one is in meters. I can't put those into my formula if they're in different units. So what I'm going to do is I'm going to change this one, 1.2 meters, using the conversion chart that was in our first lesson. To change that into centimeters, you times by 100, which makes that 120 centimeters. Okay, so now I can substitute into my formula. Half times the base, which is 80, and the height, which is 120. Third step is calculate. So half times 80 times 120 is 4,800. Now the units I chose was centimeters squared. If you choose to change into meters, that's fine, as long as you write down the correct units at the end. Okay, part D. Now this is not a rectangle or a triangle or a square, it's actually a composite shape. It's some shapes joined together. So when this happens, you want to cut it into some of the shapes that we're familiar with. So what I could do is I could cut this shape along here. Now it is possible that you could cut the shape straight down. Either way you should get the same answer, but I'm going to cut it across there. So that actually means that I've got 2 shapes here that I'm going to join together. Now this one in the bottom is obviously a rectangle, but what about this one up here? Now I don't actually know the dimensions of that one at all at the moment, so I'm going to have to work them out. If the 10 is all the way across the bottom, if I subtract off that 8, it would mean that this one here would be 2 meters. Obviously that doesn't look like 2 meters compared to the 8 over here. These diagrams are not to scale. Also, if it's 9 meters on this vertical one here, if I subtract off the 5, then that one there would have to be 4 meters. So now to find the area, I'm going to have the area of my bottom rectangle, which is length times breadth, and I'm going to have a second rectangle, which is also going to be a length times a breadth. Okay, so I've got my two rectangles that I'm going to add together. So the first rectangle is 5 times 10, or 10 times 5. Now, you don't need the brackets, but I like to put those in brackets just so I can see that is my first rectangle. Then I have a plus. For my second one, the length and the breadth are 4 and 2. So 4 times 2, close bracket. Now I want to calculate that. So you don't need the brackets, remember, it's just to help you see the two different shapes. So it's 5 times 10 plus 4 times 2 equals 58. And the units are meters, so 58 meters squared. Okay, question 2E is also a composite shape. We have got a triangle here on top, and then we have this funny shape here down below. What I can do is I could cut my shape across there as well, meaning that I've got two triangles that are the same, this one on the top and the one on the bottom, two triangles. So to find the area, I'm going to have to find the area of a triangle, which is half the base times the height, but there is two of them, so all I'm going to do is take that area of my triangle and times it by 2. Then I also need to add on to that the rectangle that is the body of that shape there. The formula for the area rectangle is length times breadth. Okay, second step is to substitute into that. So the first one is looking at the triangle. So I've got two of them, half times by. Now the base and the height of the triangles are 124 for the base, and the height is 66. Plus, now my rectangle. The length of my rectangle is 124, and the breadth is the 83. Okay, and then third step, we put it all in the calculator. So 2 times half times 124 times 66 plus 124 times 83. So it's 18476. And that is millimeters squared. Question F looks quite simple after some of the shapes that we've just been looking at. It's just a normal triangle. To find the area of a triangle, we need to do the base times the height. Now remember that the base and the height are always connected by the right angle. So the base and the height should be these two sides here. So this is where the problem has come, because I don't actually know what my base is. Fortunately, we have learned Pythagoras Theorem. This is one of the shorter sides that we could call A. To find A, we have the formula A equals big square root sign, the hypotenuse squared minus the other side, which we called B squared. So substituting into that, A is going to be equal to, the hypotenuse is 19 squared minus the 17 squared. And in the calculator, we can get an answer for that. Oops. So 19 squared, take away 17 squared, is 8.49 centimeters. Okay, so now that I know the base, I've worked out this one here, I can now finally find the area of my triangle. Area is equal to half base times height for a triangle. The base is what I just worked out, which was the 8.49, times by the height, which was 17. And that will give us half times 8.49 times 17, 72.17 centimeters squared. Okay, I have one last question here, which is a word question. Paint costs $12 per litre and can only be purchased in a full number of litres. So we can't buy half a litre or a quarter of a litre or any of that kind of thing. We have to buy whole litres. 1 litre of paint covers an area of 10 metres squared. A rectangular wall is 6.5 metres long and 3 metres high and needs 2 coats of paint. What will be the cost of paint for the wall? So we have a rectangle. The rectangular wall is 6.5 metres long and 3 metres high. So painting the wall means I need to find the area of the wall. So the area of a rectangle, which I could just call A is equal to length times the breadth. Now the length is 6.5 times the breadth, which is 3. So that's 19.5 meters squared. Okay, but I don't want to paint the wall just once. I need to paint it 3 times. So that means that the total amount that I have to paint is going to be 3 lots of that. So times that by 3. So that's 58.5 meters squared. Okay, now comes the money part and the number of litres of paint that we have to buy. Now it says that 1 litre of paint covers an area of 10 meters squared. So, and I can't buy any smaller portions than a litre. So if I need to paint 58.5 meters squared, I would have to round that to be 60 meters squared. I have to round it to the nearest 10. Okay, because I can't buy part of a litre. So because I have got to do 60 meters squared, that means that I'm going to need 6 litres of paint. Okay, so basically what I'm doing is I'm saying that I've got, if I round that to the nearest 10, I've got 60 meters squared that I'm dividing by 10, which tells me that I need 6 litres of paint. Now, because each litre costs $12, the cost is going to be 6 lots of $12 because each litre costs $12. And 6 times 12 is 72, so it's going to cost $72 to paint that wall 3 times. And you would have a little bit of paint left over. Okay, and that's it.